This section is iterated integral. The purpose of this section is to calculate double integral over rectangular domain. So first of all, let's review what is a double integral. For given function z equal to fxy, the double integral give you, think about it over a rectangle. Okay. Domain is rectangle. This surface is fxy. Now we want to find the volume under this surface. Okay. So first ask yourself, what kind volume we can find, for what kind of object in three-dimensional space. We do know how to find volume for rectangular box. However, this volume is not rectangular box. So what we need to do is break our domain to many small rectangles. Okay. So you go up, you get rectangular box. Okay. So if this area we called delta A is small enough, then you can treat this column like rectangular box. So to find the volume of this column, what we need to do is the base area, which is delta A, times the height. Just pick arbitrary sample point. fxy would give you the height. So fxy give you the height times base area, give you the volume of this column. It's approximation. Then add them together. Then after you add them together, you have so many columns. They give you approximation. Now, if you want the exact one, then you take a limit. Let delta A goes to 0. That's the definition for double integral. We call this rectangle domains R. fxy dx. dA, let me say dA. Let me write it here. This is the definition for double integral. R fxy dA. Okay. Now, to find a double integral, we're not going to use a definition to do that, which will be very difficult to do. So the purpose here, we want to see how we can calculate this double integral, which is an easy way to do that. So to figure that things out, let's look at the same problem with a different angle. Think about it, you have a domain on the xy plane. Here is A, B, C, and D. Now you go up. Now we have a surface here. Okay. Now, again, this surface here is fxy. Okay, we want to find the double integral, which give you the volume under this surface. Okay. Now, you think about this way. For fixed y here, okay, fixed for given y, you have line like this. Go up, you got a curve, okay? You have a fxy, fixed y, so this is only function of x. You got a curve like that. So you get something like this. Okay. Now, this area we called AY. For giving different y, you got a different area as I shaded. Okay. First of all, how do we find this area, shaded area? Remember, single integral gives you area under the curve. Okay. So what is a curve? This curve is on the surface with y given. So it's the only function of x. So to find this area under this curve is fxy dx. Your ay can be found by this single integral. Your x here from a to b. Okay. This is my ay. Okay, remember our goal is to find this volume. Okay. Now, if this volume is like cross section, like my ay, if they are the same, then ay times d minus a would give you the volume for the whole thing, right? However, the cross section normally are different. For different y, you got a different ay. Okay. So what we're going to do is like this. We change the y a little bit. Then you go up. You got something like that. Think about this is like slices of a bread. This whole volume is like a loaf of bread. Then I just cut as slices. Okay. Now let's find the volume of this slice of things. So since I call this difference, this thickness of your bread is dy. Okay. If dy is so small, you can think what? The cross section is the same. Okay. Therefore, ay times dy would give you the base area times the thickness, give you the volume of this slide. Okay. Then add them together. We have so many such slides. Okay. You have so many of those. Add them together will give you approximation of the volume under the surface. If you want the exact one, then you take a limit. Then let what? I call this delta y. Let me do this way. Let delta y go to 0. You can say here delta y. So what is that? That's exactly the definition of a single integral. Your y is between c and d. Ay dy. Okay, what is a? A here, what is ay? Ay here is the integral from a to b, fxy dx. This whole thing is your ax, then dy. Okay. So what is this? This gives you the volume under the surface. We just look at a different way. And what is the volume of the surface? Under the surface, exactly is what we call the double integral. So this formula tells you your double integral can be calculated by this, what we call the iterated integral. Iterated integral means we have two single integral, which we do know how to integrate it. So for the integral inside of a parenthesis, that's the integral about x. You treat y as a constant. Remember, we fix y. So after it integrated inside one, then you got a function of y. Then integrate another single integral. Then the double integral can be found. So you can do the other way. Cut your bread with fixed x. So if you do the other way, then your double integral can be found by either c to d, a to b, fxy dx, dy, or the other way around, from a to b. Think about it, you cut slides with different direction, x, y, dy, dx. Okay, now we have two integrals. Dx corresponding the inside one, x is between a and b. Dy is outside layer. The restriction for y is c to d. Okay, we call this thing is iterated integral, which can be computed. Use the things we know how to do that before. Now let's look at an example. Now we want to find the double integral over r x 1 plus, no, sorry, let me use a different one. I want to have more, I want to choose the domain is not square. Okay. Now let's look at this one. Sorry about that. X, y, e, x squared, y, dA. My r here is a rectangle. X is between 0 and 1. Y is between 0 and 2. Okay. By what we just learned, this double integral can be written as two iterated integral. Okay, if I put 0, 1 here, then 0, 2 here, then you put your function here. Okay, now, which one we should put first, dx or dy? Remember, the first one you put is corresponding to the lower limit 0 and 2, which is for y, right? So you have dy dx. If you change the order, say 0 to 2, then 0 to 1, same function. E to the x squared y, then inside one is from 0 to 1, that's the x. Then outside one is corresponding to y from 0 to 2. Okay. Now, you can calculate your double integral either by the first one or second one. Sometimes, doesn't matter which one you're using. They should give you the same answer. Okay. The problem is sometimes one is much easier than the other. There could be same kind of difficulty level, or one is much easier than the other. Sometimes one is you can integrate it, and the other one you just simply cannot do that. Okay. Okay. Now, by look at this. My experience would tell me, let me think, which one we should go first. Let's try integral 2, okay? 0 to 2, 0 to 1, x, y, e to the x squared y, dx, dy. Okay. What this means? This means you are going to integrate the integral inside the parentheses first. That's about dx. That means whenever you see y, you treat it as a constant, just like a partial derivative. Okay. Now, let's see what is this integral. Let's find the integral inside. Okay. Now, to integrate this one, this is 0 to 1 is a definite integral. How do you find a definite integral? I would suggest you go ahead, find indefinite integral, which means find its antiderivative. Once you find this, then you put it back here, replace your x by 0 and by 1, then you got it. Okay, now let's integrate this one. Forget about 0 and 1 first. Alright, now look at this integral. This integral is about x. Means you treat y as a constant. Think about y is 2, for example. Okay, or 1. So this is just a review for how do we integrate single integral. Okay. So for this case, I will try variable substitution. Okay. I would let u equal to x squared y. Remember, y here is a constant. We treat it as a constant. So your du here, y is a constant. Okay, give you 2 xy dx. All right. So we'll have this e to the u, right? Okay. This term give you e to the u. What's left? The things left is what? xy dx. Look at that. xy dx. Let's give you xy dx give you 1/2 du. So I replace the things left, which is xy dx, by 1/2 du. I got an integral about u. It's very easy to integrate it. Simply give you 1/2 e to the u. What's the e to the u? It's e to the x squared y, right? My u equal to x squared y. Okay, so we find its antiderivative. You put back here, put your antiderivative here, 1/2 e to the x squared y, then evaluate, no, not there, sorry. 1/2 e to the x squared y, evaluate 0 and 1. Now you have two variables here. You got to be careful about which variable you want to replace by 1 or 0. Okay. So this is integral about x. So you replace x by 1 first. So you got e to the y. Then subtract, replace x by 0. Okay, so you got -1. Okay, so therefore this double integral, we'll say this iterated integral, become to this. We already find it. Inside one give you 1/2 e to the y minus 1 dy. This one is easy to integrate. I don't even have to. Give you 1/2, integrate e to the y, give you e to the y, then minus antiderivative of 1, give you y. Evaluate 0 and 2. So they give you 1/2, replace y by 2, e to the 2, minus 2. This whole sense, subtract, replace y by 0, e to the 0 give you 1, minus 0. That's your answer. Okay. So you got a number here. Okay. What is that number? That number is your double integral. Okay. So we find the double integral by using formula 2. Okay. How about we try formula 1 this time? Zero to 1, 0 to 2, xy e to the x squared y. Okay. Since y is between 0 and 2, so you have dy first. Dy is corresponding to the first inside the integral, and the dx corresponding to outside one. Okay, this is just another way to find the same double integral. They should give you same thing, but sometimes one is much harder to find than the other. Okay, now let's look at this one. Okay, now let's look at the inside one. Okay, this really is two. You need to integrate two integrals. Always start with interior one, inside one. 0 to 2 xy e to the x squared y dy. We need to find this definite integral. So this integral is about y. That means whenever you see x, you treat it as a constant. Okay, now I suggest you same thing. Try this one first. Find the antiderivative. Then worry about 0 and 2. Okay, this integral, in fact, is harder to integrate it than the first inside integral. Okay, now here x is a constant. Okay, think about a special case. X is a 1, so you really need to. If x is a 1, you really need to integrate this one. Okay, for this one, how do you integrate it? Remember, for this kind of integral, we use integration by parts, right? Let me just simplify this a little bit. X is a constant, okay? You can pull that out. Well, integrate about y. Whenever you see x, treat it as a constant. So that will simplify the problem a little bit. Okay. That's the integral we want to integrate it. Alright, now let's use the integration by parts. Okay, let me write equal. Okay, let me say that again. Once you use equal sign, they got to be equal. You cannot just use this symbol if they're not equal. Okay, let me simplify this a little bit. I just integrate this. Y e to the x squared y. I have dy here, sorry. Dy, okay? Forget about this x temporarily. Okay. Now, how do we integrate this? As I told you, that we need to use the integration by parts. Okay. What is the integration by parts? U dv equal to u times v minus v du. The purpose of integration by parts is say you start with u dv, which is harder to integrate it. By integration by parts, you end up with another integral v du. Hopefully, it's easier. Okay. So, to use this integration by parts, first you have to identify your u and v. Now we call this one u, then the rest of the things is the dv. So my u here equal to y, my dv here is e to the x squared y dy. Okay, then in this formula you have to find the du and the v. So my du simply give you dy. What is my v? To find the v, you just need to integrate on the dv equation, which give you 1 over x squared e to the y, right? Try that. Then your dv would, x squared here. Try to take derivative of dv, okay? They would give you e to the x squared y, then take derivative of y, they give you x squared. Cancel with this 1 over x squared. Okay, let's write v. Okay. So u dv equal to v du. U times v. U is that. V is this. E to the x squared y. Then minus v du. V is this. Du. What is the du? Dy. Okay. So this is equal to y over x squared e to the x squared y minus the second integral. Second integral is about y. You treat x as a constant. You put that out. E to the x squared y dy. Okay. Think about that. X is a constant. Okay. So this second integral can be integrated easily. I'll give you another 1 over x squared. Then e to the x squared y. Okay, that's your antiderivative. So next thing you need to do is, let me go back, 0 to 2. Okay. Next thing we need to do is like that, 0 to 2 xy e to the x squared y dy is equal to y over x squared e to the x squared y minus 1 over x squared, 1 to the 4th e to the x squared y. This whole sense. Evaluate 0 and 2. Okay. I'm going to stop here. You are going to see this integral is very hard to integrate it. Probably we just cannot do it. Okay. I just want to use this example show you double integral can be written as two iterated integrals, which means you can use two ways to calculate your double integrals. Normally one way is easier than the other. Okay. So which one is easier, then you have to try it.